Good day, viewers. In this example, we are told that the pilot of an aeroplane flying 10 kilometers above the ground in the direction of a landmark, that's a point, views the landmark to have angle of depression at 5 degrees and 55 degrees. So what this is telling us is that it viewed it from 2 points, okay? Find the distance between the 2 points, those 2 points of observation. So it is flying at a point, he viewed the landmark. So as he's going further, he viewed it the second time. Okay, so there are 2 points of observation. So the first step in solving this problem is to draw the diagram, okay, to represent this information on the diagram before you can solve the triangle. Represent it in a diagram, get a triangle, and try to solve the triangle based on the question given, okay? So now, we can imagine this point to be the aeroplane the first time, okay, and the question says it's 10 kilometers above the ground. So 10 kilometers, okay. Now, it viewed it the first time, okay, that's 35 degrees. Then after some point, it now viewed it the second time, okay, and the angle of depression the second time is what? 55 degrees, okay. So we can now, so this is the landmark, okay, this is the landmark. We can now complete the triangle, okay. So it says, of course this is a right angle triangle. Now it says find the distance between the 2 points of observation. So this is the first point of observation, this is the second point of observation. So this is the distance in question from here to here, okay. This is what we are asked to find, okay. Now to make things easier, we can label these triangles, okay. Of course, this is also 90 degrees, okay. Now this is 10 kilometer, it's still the same height, 10 kilometer here, okay. So we can label this, we can call this place A, this place B, C, D, points A, B, C, D, okay. Now to get this point, to get the measurement of this AB, which is the distance between the 2 points of observation, we can get it by saying getting AC minus BC, okay. So we get AC, then minus BC from it, okay. Now how do we get AC? How do we get AC? Consider triangle, right angle triangle ACD, okay. If you consider triangle ACD, look at it. Huh? How do we find AC? We have 35 degrees. This is the side opposite, and AC is adjacent. So opposite and adjacent, we use tan, okay? So tan 35 degrees is opposite over adjacent. And the opposite is 10 over adjacent is what? AC. Okay? So if you, so we have 35 tan 35 degrees equal to 10 over AC. If we cross multiply, or we can times AC this side, we have tan 35 degrees times this AC is equal to 10. So to find AC, AC is equal to what? 10 over tan 35 degrees, which is what? 10, 1 over 10, 35 is what? Cot 35. So AC is equal to what? 10 cot 35 degrees. Okay, so we have gotten AC. Now let's get BC. To get BC, consider right angle triangle BCD. Okay, we'll do similar thing we did here. 10 is opposite. BC is adjacent. So use SOHCAHTOA. So TOA, opposite adjacent, goes with tan. So tan 55 is equal to opposite over adjacent. What's the opposite? 10 over adjacent, which is BC. So that means tan 55 is equal to what? 10 over BC. Okay? So cross multiply BC here, you have what? 10, 55 times BC is equal to what? 10. So what's our BC? BC equal to 10 over tan 55, which is what? 10. No, 1 over 10 is what? Cot. So this is 10 cot 55 degrees. Now, remember that AB, side AB is equal to AC. That's AB is equal to the whole of this minus this. Will give you this. So AB equal to AC minus BC, which is what? 10 cot 35 minus 10 cot 55. So 10 is common. Factorize that 10. So you have what? Cot 35 degrees minus cot 55 degrees. So the distance between the 2 points of observation is AB, which is what? 10 cot 35 minus cot 55. So the answer is option D. Thank you for listening.